Can you be able to solve this question under what? Operational what? Amplifier, which is also known as what? The op-amps. Now, this is what? Inverting what? Op-amps. Why is it called inverting op-amps? It is called inverting op-amps because the V in, which is the input voltage, is at the what? Negative side. But whenever the input voltage is at the positive side, is known as what? The non-inverting what? Op-amps. Now, what are we asked to solve? We are asked to find the output what? Voltage. Okay, we are asked to find the output. This is the output what? Voltage. Now, what is this operational what? Amplifier, which is also known as the op-amps. Okay, now this is designed to take the small what? The small voltage input to produce a larger what? Voltage output. Okay, a small voltage input to produce a larger voltage output. This is how this op-amps is being designed. It's being designed to take a small voltage input to produce a larger what? Voltage output. That's how it's being what? Designed, right? Take note that your amplifier, it takes a small signal to produce a larger signal to make it strong and stable, right? Now, what are we going to do? Because we are asked to find the what? Find the output voltage in this question. And don't forget that this op-amp you are seeing is known as what? You are injecting what? This is called what? This op-amp is called what? Inverting. Sorry, inverting what? Inverting op-amps. It's very important, right? Inverting what? Op-amps, which is also known as your what? Operational what? Amplifier injecting what? Op-amps, which is called operational what? Operational injecting what? Sorry, not injecting, inverting what? Op-amps. This is inverting op-amps. Now we are asked to find the output voltage. Now I want you to understand something very interesting. This resistor you are seeing here is called the what? It is called the feedback resistor. And this arrow you are seeing that you call the feedback what? Feedback current. This is the feedback current. And what you are seeing here is the what? The input resistance, which is the arrow in. This is the input resistor, and this is the input current, which is I in. Right? Now, by obeying our what? Our KCM, which is Kirchhoff's current law. Kirchhoff's current law states that the algebraic sum of the current across a load or across its loop is equals to the sum of the current leaving the loop. Now, if this current, which is this feedback current, which is IF, is coming to this direction, which is this is a loop, right, which is a junction, and this other current, which is arrow I in, which is input current, is coming to this direction, and the sum of this and this will give us this. So what is here? Here is our I, which is our total current, right? Now, by using KVA, KVC, KCM, which is Kirchhoff's current law, that means IF plus I what? I in is equals to what? I. This is by KCM, which is our Kirchhoff's current law, which states that the sum of the current across a loop is equals to the current leaving the loop. That means the sum of the current entering into the loop is equals to the current leaving the loop. That is the Kirchhoff's current law, right? But at this point, there's something very important. Now, if this plus this will give us this, and take note that in ideal operational amplifier, that I is equals to 0. I you are seeing is equals to 0. Why? Why is it that I is equals to 0? I is equals to 0 because you do what? At this point, which is the negative sign, look at IF, which is feedback current, is coming to this direction, and arrow I in, which is input current, is coming to this direction. Plus these two will give us this I. But why is it that I is current? I is 0 because it's infinite what? Infinite current. Okay, that means there's no current flow into the what? The input or the output. You can see if this is going to this direction and this is going to this direction, so this plus will give us I. But at this point, as having a negative sign, it means that there's no flow of current. Okay, so that means I is what? Is 0. So if I is 0, we now see that feedback what? Feedback current plus feedback current and input current is equals to what? 0, right? That means that IF is equals to minus what? I in, by subtracting what? Subtracting I in from both sides. You can call this equation 1 and can call this equation what? Equation 2. Take note that why this is what? Infinite what? infinite what current. That means there's no current flow into the terminal, right? The pin. So at this point where IF is equals to minus I in, this is equation 2. Then from what? From the input, let's say from the input, don't forget that this is what this is your V in, which is your input voltage, right? So that means V in, let's find the drop here, the current drop here. The current drop here will be what? Will V in minus what? Minus your I equals to what? I in multiplied by what? Arrow in. Arrow in is the what? Input resistance, input resistor. Now by dividing both sides by arrow to make I in the subject, dividing here by what? Arrow in, so that this cancel out this. You see that our arrow in, sorry, our I in is equals to what? Since this is 0, it means that it's equals to V in divided by what? Arrow in. I can call this equation what? Equation 5. And this is equation what? This equation what? Equation 3, right? Equation 4. Wow. This is amazing. That means this is the current drop across what? The input, from the source, from the input. Now let's say from the output. From the output, let's see the voltage and the current drop at the output. So the current drop at the output will be what? Will be VO minus what? I is equals to feedback current multiplied by what? Feedback resistor. Feedback resistor, right? So by dividing both sides, I know that this is 0 because it's infinite current. So it means that VO is equals to IF multiplied by arrow F. So by dividing here by arrow F and divide here by arrow F, means that this will cancel out this. So IF is equals to VO divided by arrow F, right? So you can call this equation 5, and this equation 6, right? Now let's put equation equation 4 and equation 6 into what? Into equation 1. So into equation 2. That's what we're going to do next, right? Now let me explain further. Now here is the current drop across the what? The input source, which is the V. V is the input voltage. This is the current drop. Then this is the current drop across the output. Okay, this current drop across the output. This is what? Current drop upon. Let me just write it. Current drop. This current drop what? Current drop across what? Across input voltage. Then here is the what? Here is the current drop across the what? Across the output. You know this is output. Current drop across the output. Now we're going to substitute equation 4 and equation 6 into equation 2. So let's do that quickly. So I can remove this from here quickly. Okay. Now we know that from equation 2 that IF is equals to minus I in. So by substituting this, let's see IF is what? IF is VO divided by what? Arrow F equals to minus into I in is what? V in over what? Arrow in. Then by cross multiply, this is VO is equals to minus V in divided by what? Arrow in, and here is arrow F. Cross multiply, VO multiplied by arrow in is equals to minus V in multiplied by what? Arrow F. So what are we going to do here? Remember, if you are going to look for a closed loop gain, that means closed loop gain is equals to what? VR divided by what? V in. So what you are going to do here, divide here by V in to divide here by what? V in. So that this cancel out this, you see that VO divided by V in multiplied by arrow in is equals to minus arrow what? Arrow F. So what are we going to do? Because I said earlier that if you can have VO over V in is our closed loop what? Closed loop gain. Okay, that's general gain with no special simplify. Okay, so that means from here our VO divided by V in is equals to minus arrow F divided by what? Arrow what? In, by dividing both sides by arrow in, right? So since we know that closed loop gain is equals to VO over what? V in, it means that our closed loop gain is equals to minus arrow F divided by what? Arrow in. This is the formula of closed loop gain in what? In inverting what? Op amps, right? Now remember the question says you find the output voltage. Find the output what? Voltage. From here you can find the output voltage. It means that output voltage is equals to into minus arrow F divided by arrow in, okay, multiplied by arrow in V in. So this is the formula of output voltage. This is formula of what? Output what? Output voltage. Output what? Voltage, right? Wow, this is amazing. So let's find, that's what we have to find. So before you can find the output voltage, we have to determine our what? Closed loop what? Closed loop gain. So our closed loop gain will be equals to R minus arrow in. What is minus arrow in is what? Minus 40 what? 42k ohms divided by arrow in is what? Arrow in is 2k. You have 2k ohms, right? So closed loop gain will be equals to, this is minus 42,000 because k is 1,000. 1,000 times 42 gives us 42,000 divided by 2,000, right? So that means this will cancel, 0 will cancel out 0. So you see that closed loop gain is equals to what? Let's see, minus 42 divided by 2, we have what? We have minus 21. We have minus what? 21. So the closed loop gain is what? Is minus 21. Now, since we are getting that this is closed loop gain, so that means we can find our what? Our voltage output. Okay? For us to determine our voltage output is very simple. Just substitute into the formula and we are done. So it means that our voltage output we are looking at, we are finding will be what? Into minus 21 multiplied by V in. And V in is 20 milliamp. 20 what? Millivolt, sorry. And take note that millivolt, you're seeing is 10 raised to the power minus 3. So it implies that V at will be equals to minus what? 21 multiplied by what? Multiplied by 20 multiplied by 10 raised to the power what? Minus 3 what? Volt. Wow, this is pro-extraneous, right? Now at this point, what are we going to do? We want to do something very interesting. That means V at is equals to into minus 21 multiplied by what? Then 20 multiplied by what? I can do something very interesting here. This can also be seen as 0.001 volt, right? Because if I put in the decimal place, I'm going to see 1, 2, 3. So let me multiply 20 by what? 0.001. I have 0.02. So that means V at is equals to into minus 21 multiplied by 20 multiplied by what? So I already multiply it, so I'm going to have 0.02 volt. So let me multiply by minus 21, multiply by minus 21. I have V at is equals to minus 0.42 volts. And this is the output what? Voltage. So for me to put it in milliamps, I'm going to divide the answer by 1,000. I want to see, let me see, I have minus, I'm coming, minus 0.42 divided by 1,000. Or let me multiply by 1,000. Multiply by 1,000. So okay, I have V at equals to minus 40 what? Minus 42 minus 462 milliamp. Wow, this is amazing. So for me to remove it from here, you have to divide it by 1,000. So let me divide by 1,000. Let me see. Okay, so this is in volt and this is in milliamp. So this is the solution to the question. This is what you are asked to solve. You are asked to solve for the output what? Voltage. You can see, find the output what? Voltage. And for us to find the output voltage, you have to know our closed loop gain. And our closed loop gain is minus 21. Remember that gain does not have any value. Okay, so it was minus 21. If you multiply all this, you will have this. So we'll put it in, this is in milliamp because it's minus 420 millivolt. This is minus 0.42 volt. So for us to put this in milliamp, we have to multiply this by 1,000. That's why you're having minus 420 milliamp. For you to remove from milliamp, you have to divide by 1,000. Wow, this is amazing. So thank you so much for watching. If you find it very interesting, don't hesitate. This is our channel, Sagas Online Maths. We also solve most questions related to mathematics, also our electronic engineering courses. And take note that this course you're seeing is for level 300, right? Level 300 in what? EEC 314. That's analog electronics. So this question is from what? Is from operational amplifier, which is also known. Remember, we have two operational amplifier. We have the inverting op amp and non-inverting op amp. There are so many. Okay. So this question you are seeing was getting from our what? Our analog electronics for 300 level. So if you know you really find it very interesting, don't hesitate to like, comment, and share to loved ones. And if you know you're not subscribed to our channel, kindly do so.